production, boost crop yields and sustainability, proven strategies to improve nutrient use efficiency in agriculture. As global food demand rises, environmental concerns grow, low nutrient use efficiency has been identified as a critical constraint to achieving high yields and sustainable farming system. Therefore, improving how crops absorb and use nutrients has become essential. According to the Food and Agriculture Organization, less than 50% of the nitrogen applied, applied to crops is absorbed by plants. The rest is lost through leaching, volatilization, or runoff, leading to groundwater pollution and greenhouse gas emission. By improving nutrient use efficiency, farmers can increase yields, reduce production cost, and minimizing negative effects on soil and water system, thus ensuring long-term sustainability. This reviews the understanding of nutrient use efficiency, the factors that influence it, and strategies to improve it to ensure sustainable crop production. It also discusses a few case studies and research findings and provide recommendation for future intervention. Understanding nutrient use efficiency. Nutrient use efficiency refers to how effectively a plant takes up and uses nutrients, especially nitrogen, phosphorus, and potassium, from the soil to produce economic yield. In simple terms, it refers to how much output means grain, fruit, or foliage a crop produces per unit of nutrient applied. Why does nutrient use efficiency matter? Improving nutrient use efficiency is important for sustainable farming. Low nutrient use can result in declining soil fertility, water contamination, for example, nitrate leaching, high greenhouse gas emission, especially from nitrogen fertilizer, increased farming cost due to excessive fertilizer use, inappropriate fertilizer application, soil degradation, and limited access to modern agronomic technology have led to inefficient nutrient cycling, resulting in yield stagnation and environmental degradation. Key factors affecting nitrogen use efficiency. Nutrient use efficiency. Several variables influence how efficiently crops use nutrients, and understanding them is essential to designing intervention that can improve nutrient use efficiency effectively and sustainably. Soil property number one, soil properties, soil pH, texture, structure, organic matter, and microbial activity influence nutrient availability and their uptake by plants. Crop type and variety. Different crop species vary in their ability to absorb and utilize nutrients. Third, fertilizer resource and application. The type, timing, and method of fertilizer application, granular, liquid, coated, greatly affect efficiency. Fourth, environmental condition. Temperature, rainfall, and water management determine how available nutrients are to plants. For instance, high temperature can accelerate nutrient volatilization, and excess rainfall may increase nutrient leaching. Cropping system and management practices. Monocropping, improper crop rotation, and inadequate soil fertility management reduce nitrogen use efficiency, nutrient use efficiency over time. Strategy to improve nutrient use efficiency. Improve nutrient use efficiency for sustainable crop production requires a multiple dimensional approach that integrates agronomic practices, technological innovation, and institutional support. The following strategies have been proven effective in various cropping systems: soil testing and nutrient budgeting. Regular soil analysis helps to determine actual nutrient needs, preventing under or over application. A nutrient budget matches inputs with crop demands, reducing waste. Integrated nutrient management. Integrated nutrient management involves the combined use of organic and inorganic sources of nutrients to meet crop needs. Farmers can integrate compost, green manure, mineral, and fertilizer to improve nutrient availability. Soil health and microbial activity. It promotes balanced nutrient application and reduces dependency on synthetic fertilizer, thereby improving overall nutrient use efficiency. Precision agriculture. Using GPS guided equipment, drones, or soil sensor allows for targeted fertilizer application. This site specific approach reduces input cost and increases uptake. Split application and timing. Rather than applying all fertilizer at once, splitting doses based on crop stage ensures nutrients are available when plants need them most. Slow release and coated fertilizer. These products release nutrients gradually, minimizing losses to the environment and improving plant uptake. Improved crop varieties. Breeding for nutrient use efficiency traits such as improved root system is a promising strategy in modern agronomy. Conservation agriculture practices, cover cropping, and residue management contribute to improved soil structure, microbial activity, and nutrient retention. For example, mulching with crop residues can minimize evaporation, nutrient leaching, while legumes or rotations fix atmospheric nitrogen, reducing the need for external inputs. These practices improve soil structure, microbial balance, and nutrient retention, leading to higher nutrient use efficiency. Farmer education and extension services providing farmers with access to knowledge and tools for improved nutrient management is essential. Training in soil for testing, fertilizer calibration, and interpretation of nutrient deficiency symptoms can empower farmers to make informed decisions. Additionally, extension agents can facilitate the adoption of new technologies and best practices. Benefits of improving nutrient use efficiency. Number one, higher yields. Efficient nutrient uptake leads to better growth and higher harvest. Second, lower input cost. Farmers can use less fertilizer while maintaining performance. Third, environmental protection. Reduced nutrient loss preserves water bodies and reduce emissions. Fourth, soil health and balanced nutrition maintains soil structure and biodiversity. Case studies and research finding. Recent studies and field-based experiments across different regions have demonstrated practical advancements and the measurable benefits of improving nutrient use efficiency. These examples reflect the successful integration of strategies discussed earlier were adapted to local context. Genetically enhanced sorghum in Nigeria. The Institute for Agriculture Research in Nigeria released a sorghum variety bred for high phosphorus uptake. The variety outperformed traditional types by up to 35% in grain yield when grown under low input conditions. Farmers in semi arid zones who adopted this variety experienced improved nutrient use efficiency, especially under limited fertilizer availability. Use of precision agriculture in maize production. In Kenya 2022, a study examined smallholder maize farms in western Kenya where precision agriculture tools, namely soil sensor and variable rate fertilizer application, were introduced. The results showed a 25% increase in maize yield and a 30% reduction in fertilizer uses, indicating improved nutrient use efficiency and profitability. Rice wheat cropping system in India. Integration of CRPF and 4R practices in 2021. In northern India, Sharma and Gupta 2021 conducted a field trials on rice wheat system using controlled release fertilizer and the nutrient steward principles compared to conventional urea application. The CRF based treatment resulted in 40% higher nitrogen recovery efficiency and 18% greater crop yield. Moreover, there was a significant decline in nitrate leaching and greenhouse gas emission. Integrated soil fertility management in Ethiopia highlands in 2020. A multi-year project tested ISFM practices including compost application, crop rotation with legumes, and micro dosing of inorganic fertilizer across various wheat farms. Nutrient use efficiency improved by an average of 28% with reduced input cost and increased food security for participating households. Digital advisory tools in Ghanaian cocoa system in 2024. A recent innovation led by Agritech Ghana introduced mobile-based nutrient advisory platform tailored to cocoa growers. These tools provided customized fertilizer recommendation based on GPS location, soil testing, and climate data. Over two cocoa growing season, participating farmers reported up to 20% better pod yields with 15% less fertilizer, showcasing the role of digital innovation in improving nutrient use efficiency. Conclusion. It can be concluded that based on the findings from recent studies and the challenges identified, the following recommendations are proposed to improve nutrient use efficiency to promote sustainable agriculture, precision agriculture, and technology adoption. Governments and development organizations should prioritize funding for precision agriculture technologies, including soil sensor, drone monitoring, and variable rate fertilizer applicators. Subsidies or financial support mechanism could be introduced to make these technology more accessible to smallholder farmer. Extension services should also be strengthened to ensure farmers can effectively use these tools. Soil testing and specialized fertilizer recommendation. It is essential to improve soil testing infrastructure and the delivery of specialized fertilizer recommendation to farmers. Increase access to affordable soil testing and personalized nutrient management plans would help optimizing fertilizer application, leading to higher nutrient use efficiency. Educational campaigns should raise awareness of the importance of soil health and nutrient management. Farmer education and training. Farmer education programs should focus on enhancing knowledge about sustainable nutrient management practices, including the use of organic fertilizer, crop rotation, and agroecological practices. Training should be targeted, practical, and region specific, providing farmers with the skills they need to make informed decisions about nutrient application. Use of Integrated soil fertility management, promoting integrated soil fertility management, which combines organic and inorganic fertilizer use along with soil conservation techniques, can help improve soil health and nutrient cycling. Governments and NGOs should support the widespread adoption of ISFM practices by offering training and resources to farmers, particularly in regions with degraded soils. Implemented supportive agriculture policies. National governments should develop policies that incentivize sustainable nutrient management practices. These policies could include providing financial incentives for farmers who adopt best practices for nutrient use efficiency, improving access to credit for purchasing fertilizer, and phasing out subsidies for inefficient fertilizer use. Furthermore, policies should encourage research into the development of crop varieties with enhanced nutrient use efficiency traits, foster international collaboration and research. Countries with similar agronomic countries with similar agronomic challenges should collaborate on research initiative in a research initiative focus on improving nutrient use efficiency. Sharing knowledge and innovation can accelerate the development of region-specific solutions, and collaborative efforts can help scale up successful strategies globally. International agricultural bodies such as FAO and IFA should continue to support nutrient use efficiency research and promote best practices. Please subscribe, like, and comments.